Hello and welcome to SQA Higher Maths. Applying differential calculus. Today we are looking at optimization. So what is optimization? Well, we are looking to find some optimal values of a certain function here. So we're looking for the highest or the lowest value. So it is very much like finding maximum and minimum turning points, except there is quite often a little bit of problem solving to be done at the start. So this is basically maximum and minimum values along with a little bit of context. So I'll let you guys have a read of this in your own notes, but we'll scroll down and go into an example straight away. So example number 1 here, I'm just going to do 1A in this video because it'll take a little bit of talking about, and then I'll do 1B in a second video. So 1A is the tricky part. Question 1B is just basically doing a turning point question once we've got 1A sorted out. The important thing to remember in a question like this, guys, is that if you can't work out how to get 1A, the vast majority of the time it is a show that question. So it's basically giving you the answer, so it's not stopping you moving on to part B to try and get the kind of 5 or 6 marks that are available in part B. So have a go at part A, always have a go at it. Always write down what you're told in the question. But if you're not quite getting it out, then always have a go at part B, because you're basically starting with this in part B. Okay, so we've got a small wooden tray here. It's got a square base of length and width x. It's got a height of h, and the volume must be 108 cubic centimeters. So the total internal surface area of one tray is given by this function of x. And part B, find the dimensions of the tray using the least amount of wood. Right, so we need to show this. So what is the surface area, the internal surface area? Well, that is the area of all the surfaces. So as we can see here, we've got 4 rectangles for each side, plus we've got the square. That is the base, there's no lid on it. So we've basically got 4 rectangles and 1 square. So the surface area will be x squared plus 4xh. Where's that coming from? Well, the base is x by x, so that's x squared. The front here is x multiplied by h, which is xh. The side, the right-hand side, the left-hand side, and the back side is also xh for the area. So we've got xh multiplied by 4, which is 4xh. So all I've done there is just found the area of a rectangle and a square, added them together. What else are we also told? Now, hang on just a second. So the surface area, this looks like this, but we don't have an h. We have 432 over x. We might be looking at that thinking, where on earth how on earth are we going to change that to 432 over x? So the fact we've got an x squared is encouraging. What else are we told? We're told the volume must be 108 cubic centimeters. So volume of a cuboid, length times breadth times height. So the volume would be x squared multiplied by h. So again, length times breadth times height. So x multiplied by x multiplied by h. So we're told the volume must be 108. So 108 equals x squared h. So we've got these two pieces of information. All I've done is written them down. Now I'm looking thinking, there's no h in the answer that they want us to get. However, both of these equations have an h in it. If I can rearrange this second equation in terms of to make h the subject, then I'm just going to substitute in. So let's divide through by x squared. And then just substitute in. So rather than x squared plus 4xh, which we had originally, we'll have x squared plus 4x multiplied by whatever h is in terms of x, which is 108 over x squared. So x squared plus 4x multiplied by 108 over x squared, and 408 are 432. X divided by x squared would just leave an x term on the denominator, and that is exactly what we've been asked to show. Okay, part B I will do in a separate video, but just to recap, you'll be told 2 pieces of information, get them both written down, and then rearrange and substitute in. So each of these questions are different. It's not, it's not the same. A lot of questions in higher maths, if you learn the process, you can do them. There's definitely a problem solving element to these ones, but always have a go at part A.